This movie will go through the cut and place commands in the surface mining module. These are found in the surface pull down, and they range from define dragline equipment down to process dragline sequence. We'll hit some of the highlights of these commands and process to 3D. First thing that's needed is a cross-section or fence diagram through the geology using the real grids, and that's done with the fence diagram command under StrataCalc fence diagram. We will draw them on a 2D grid through the pre-calculated grids. We'll have it do the draw surface polyline. That way it will draw a continuous polyline all the way through the pit. Make sure the scales are the same. They're both 100, 100. We'll do grid ticks only so there's no grid lines. Turn off draw geologic columns. We do not want to hatch the fence. We want to draw them as single polylines. That way they're not closed. There's one more setting for label pit lines. Here it is. It's a drop down. Label pit lines up to the bottom strata polyline. I'll hit OK and grab the range diagram pre and pick this polyline cross section. And then crossing select and grab the pits to label. Choose the elevations and place your cross section over here. You can delete these partial topo lines, and that leaves then the continuous ground surface line. There you can see the pit lines are drawn up to the bottom of the strata. Our center line, when we go to 3D, we'll need to process it down, up and down a center line, and that's this polyline that crosses the cross section right at the front or the beginning of pit A1. And so that center line reference point is right there. Now we're done with the fence diagram, so we'll go into the surface mining, and it's helpful to keep a running copy or history of your fence diagrams. So I'll just make a couple of copies, that way we can always back up if you want to start over and try a different option. And we'll just place the dragline onto this surface topo with draw dragline limits. The program comes with about 40 or so different drag lines from different spec sheets or different mine locations, and those are defined under define dragline equipment. If you edit one, you can see there's the required sizes for dimensions and then the optional sizes. So we'll now place the dragline with draw dragline limit, and let's go with a 2570. Select the ground polyline. Pick a reference point. Let's say I want to pick the end point, crest of the high wall, right about there. And we'll place the center pin of the tub about 55 over to the right. So here you have the swing angles labeled up top, and this is your digging depth and dump and digging reach horizontally. Horizontal and vertical dimension. We're ready to start with the first cut in place spoil removal. The scales are the same. We'll do a 20% swell factor. The high wall angle left will be 65. The right side 65. Angle of repost 36 degrees. Track undisturbed ground polyline if you wanted to check and monitor the rehandle. That allows you to generate the rehandle volume based on two different polylines. I will place my pile by top of pile, and I'm going to define the cut by points, and we're going to make a new sequence file. We'll just call this movie 1. Select the current ground polyline. The center line reference point, I'll just do the endpoint snap to right there. Bottom strata, what we're digging down to, is the top of this first coal seam, and we'll just call it top of coal 1. Pick the lower left corner, and notice I have my snap off. I just do the one-time snap. This command works better if the O snap is turned off and you just grab them from a toolbar or shift right click. We'll move over to the right, make our pit 200 exactly. You can just pick close and put in 200. Now I'm attached to my spoil peak, and I'll place it right there within the reach. And this is your inspector window to show you the dimensions and slope where you placed from and to. Now if you want to change anything, I can say change my right cut point, and as you slide that right cut point in or out, notice the dynamic spoil changes to match your volume and area. Move it back to the 200 and hit OK. Now on this one we'll take out the first coal seam. We'll go up to surface, cut only, pre-strip or coal removal. We'll do 89 degrees on the coal face slope. This is sequence step 2, automatically incremented, and we'll now select the existing grade. Centerline reference point is the same, and select what we're digging down to. This time is the bottom of the first coal seam, and we'll call it BOC1, bottom of coal 1. And we'll just pick the lower left of the coal and then over 200 feet. Control point to adjust, none, it looks good. Enter to end. Now we'll take out this interburden. I will go to flatten spoil top. We're going to push it all to the left, a distance of 200 feet. And we'll add that to the sequence as step 3. Now we have a place for the drag line. We'll draw drag line limits. Erase the old limit, yes. Reference point will be this corner, and we'll locate it on negative 55 feet left from there. So now we have the reach to remove this interburden. Back to surface, cut and place spoil removal. This time my high wall angle left will be the angle of repose, 36. Everything else should be fine. Hit OK. Pick the current ground. Centerline reference point is the same. And we're digging down to the top of coal 2. TOC number 2. Okay, lower left cut point. I'll turn on my O-snap and we'll go right to the top of coal to try and leave as little fender as possible. Over 200 feet. 200 exactly. And then we have plenty of room to throw and cast the spoil up here. Well within the reach. Control point to adjust. Enter for none. Looks like my lower right cut point. I did notice that. My lower right cut point here is just outside the reach. But I think we'll go ahead and process it anyway. Just to show you that that message does appear, but you can move on through it. Just to take out the last coal seam. Cut only, coal removal. Existing ground, centerline reference point. Pick the strata we're digging down to, which is the pit floor now, and we'll call it BOC2. Then we'll pick the lower left corner and over 200 feet. Actually, for this one, I'm going to snap to the intersection of that pit, and I'll change my lower left cut point as well to snap to that pit floor and the A2 line intersection. Okay, so now we're ready to go. Process that to 3D. I'll make this line a little thicker for visual using my line weight. There's the finished result. We have everything we need for process to 3D. It's called process dragline sequence. We do have a polyline to centerline file. I'll go ahead and run that just to show the step. We'll just call it centerline. Replace it, yes. And the centerline is this polyline. That's what it uses to apply that suction up and down to the plan view in 3D. And we're ready to go to process dragline sequence. We'll do multiple along the center line. Grab the sequence file called movie1. The center line, we just made it. Center line. And the section or surface topo grid. And then we'll also do an output. We'll call it range diagrams section output. We don't need pits. We do want the section lines. And for tons, we'll do an 80 and the layer is dragline. Select the grid for strata top of col 1. That is the bottom of overburden. Bottom of col 1 is the C1 elevation. Top of col 2 is the inner burden floor. And the bottom of col 2 is the C2 elevation. We'll do every 100 down the interval, 2000 left and right of the center line. And just as we expected, we are outside the lower right cut point on all those last steps, but that's just fine. It still did it. And now what we'll do is isolate that layer. I'll do the triangulate and contour TRI command just to draw some triangle faces for viewing in 3D. And then we'll go into the Carlson 3D viewer window. Okay, pull it straight down, rotate around, and zoom in to see what we've done. It should look exactly like we designed. There's our first spoil and second spoil. You can see the first col seam, inner burden, second col seam over on the right hand side. It's a very nice representation of our range diagram cross-section design, now converted to 3D. Exit there. And lastly, we did create that section file output, so I'll go into the sections pull down, and we'll just run draw section file. Grab the output section called range diagrams. Scan file to set defaults to match up all the stationing. Hit OK, and we'll place them over here. Just another alternate output of the design. We'll zoom in and check it out. Maybe change the color of this light blue, cyan, to dark blue. And there we have cross sections every 100 going down the pit. Okay, well, this concludes the quick flow of the cut and place series of commands from define dragline equipment down to process dragline sequence.